Report range status.
Range green.
That's good to hear, Joshua, right there.
Public safety there is accounted for, the FTS system. There you see on your screen a beautiful shot. The skies look great. There's little wind happening. You'd be able to see more of the venting. If there were wind, the trail of that venting. So we're ready to go.
And actually, that's an important point. The reason we don't see that venting is the vent valves have been locked up to put flight pressure into the tanks. And as we just heard, they're stable at step 3, which means the tanks are ready to go. And here at about 5 seconds, we will hear the team
ECS reduced for launch.
Give the final go.
25 seconds.
Status check. Go Atlas.
Go Centaur.
Go Mars 2020.
There we go. We are ready to go lift off this morning, Joshua.
Eight, 7, 6, 5, 4. Engine ignition. 2, 1, 0. And liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
And Atlas TU has gone to closed loop control. Coming up on 30 seconds into flight, the RD-180 is throttling down as expected. Engine response looks good. And Mach 1 Atlas V is now supersonic. And passing 45 seconds into flight, vehicle is now passing through max Q, maximum dynamic pressure. Passing 1 minute into flight, the RD-180 is throttling back up as expected. Engine response looks good. At this time in flight, the SRB chamber pressures remain nominal. The RD-180 pump speed and fuel injector pressures are responding well to demands on the engine. Standing by for SRB burnout shortly. And we have burnout on all 4 SRBs. Burnout pressure signatures look good. Standing by for SRB jettison shortly. And we have a good indication of SRB jettison of all 4 SRBs. And the vehicle has gone to closed loop guidance. Vehicle body rates are responding nominally at this time. And coming up on 2.5 minutes into flight, the RD-180 is throttled down slightly as expected. Engine response continues to look good. At this time, the vehicle is 50 miles in altitude, 85 miles downrange, traveling at 6,000 miles per hour. And the Centaur reaction control system is now pressurizing to flight levels. And just past 3 minutes into flight, the RD-180 is now throttling to maintain a constant 2.5 G acceleration limit for payload fairing jettison. Engine response and vehicle acceleration look good. And we have good indication of payload fairing jettison and Centaur forward load reactor deck jettison. And the RD-180 is throttling back up to attain a 4.6 G acceleration. Engine response continues to look good. And Centaur has begun the boost phase chill down sequence to thermally condition the RL-10 for operation. Standing by for BECO shortly.
BECO is the call for booster engine.
And we have BECO, booster engine cutoff, standing by for stage separation. And we have good indication of Atlas Centaur separation.
So there you're seeing live footage.
And we
from
have
the rocket.
MES-1. RL-10 operating parameters look good. Chamber pressures are stable. This will be the first of 2 burns for today's mission. This first burn will be approximately 7 minutes in length.
So, Mick, that's pretty exceptional footage there. That's live video. We will see that switch over shortly into an animation that kind of helps let us know what's happening with the rocket. But right there, a beautiful liftoff. Fun to feel that rumble in the building here as we proceed towards orbit and then towards Mars destination.
Yeah, absolutely. It was great watching an on-time liftoff of the Atlas V with that little over 2 million pounds of thrust. Cleared the tower in roughly 5 seconds. Josh, you and I worked the InSight mission, and if you recall, that mission on the West Coast took about 17 seconds to get past tower. So with those 4 solids today, this thing really got out of here and on its way. It's, as we hear from Jesse, everything's looking nominal, and all vehicle parameters are within the design limits, and we're getting ready to come up on a main engine start for that first burn that Jesse was talking about.
Yeah, so recapping this countdown to Mars, the stations began to be filled up this morning just after midnight. Preparations, fuelings, powering up, all the way through that liftoff that happened. I think, Mick, it wasn't precisely on time. I think you said it was like 10 milliseconds early. So it's pretty much dead on.
Yeah, dead on. This team does a great job. As I said, they're very focused, very disciplined. As Tori also said, courageous. They have done a lot of work to get us to this point today through this pandemic, changed how they did some of their work, made adjustments as needed, a lot of cleaning, a lot of things, a lot of wearing their face masks, doing all kinds of things. And so this is an exciting time, not only for the JPL team in Mars 2020, but everybody that's worked this mission and for the country and the agency. So this is exciting to see. We still have a long way to go, Joshua, before spacecraft separation.
Yeah, we had a really quiet countdown today, which is phenomenal, that we got off the ground on time. And we are proceeding now that we are in the middle of the first burn. It's tough to make out, but that engine is lit and it's firing. So we are in motion. There you go. There's that animation we talked about.
The telemetry there as we switch to a TDRS compatible data format.
TDRS.
Overall telemetry quality is very good.
The space tracking system. So there you go. This is not an actual video, but this is an animation that's driven by real data. So although we're not actually seeing the engine on screen right now, we can see that the engine is lit, and that is driven by the data that says that the engine is truly lit and we're in this burn.
Yeah, the launch vehicle continues to send telemetry to the launch team via the TDRS network, as you mentioned, and that allows them to continue to watch what's going on and make sure all their sequence of events meet their timeline. We continue on a nominal flight this morning. This first burn, as we heard earlier, will be about 6 minutes. This will get us into that park orbit around Earth, allow us to get on our way, and then get into that approximately 30-minute coast period that we're going to have.
8 minutes into flight, beginning to see the Centaur PU system balance out mass errors, seeing very stable body rates in the Centaur.
So we've mentioned 5 teams at play, and although if you were watching, hopefully you got a chance to see this in person, if not on camera, it's easy to kind of say, oh, it's over, like job done, but all 5 of these teams still very much engaged, still very much focused, because there's a lot of work ahead as we proceed through this first burn, and then a coast phase, like you mentioned, Mick, and then a second burn, and then spacecraft separation and the acquisition of signal from Mars 2020. So a lot more coming up here. Mick, I know for Launch Services Program, you guys manage the launch. So what does that mean? I mean, this is you guys' work in action right now.
By the way, that's the 5th team that we didn't get to mention. We talked about JPL, we talked about DOE, we talked about United States Space Force, and United Launch Alliance. LSP, we are like the brokers to select this launch vehicle and help with manage this mission. So we get our spacecraft customer, the JPL folks, they come to us. They have some certain requirements that they need for this mission. The launch services program made up of engineers and flight analysis folks, and they look at everything, they help define those requirements, and then we go out and procure a vehicle from a commercial partner. In this case, it was the Atlas 541 for the Mars 2020 mission that was needed for performance, right? As you and I have talked over the last several days, Josh, one of the things that was important for us to look at was that performance, to be able to get Mars 2020 onto that transfer orbit into solar orbit to intercept Mars in 7 months. It's kind of analogous to a football game, right? With a quarterback trying to throw a pass downfield. You need a quarterback with a lot of performance who can get that ball down there where it needs to be, so the receiver can intercept that. In our case, 7 months later.
There you go. Yeah, it's the longest football pass ever. The Earth is the quarterback. The Atlas is the quarterback's arm. Perseverance is the football, and Mars is the receiver.
That's exactly right.
And what we also talked about is that technically, you could launch to Mars at any time if you had a rocket that was powerful enough. But this is the launch period every 26 months or so, as we've talked about, that makes the most sense because you require the least amount of energy to get to Mars, because it takes a lot to get there. Obviously, like the Atlas 541 is a workhorse.
Yeah, as Tori said, it's their Dominator. Right?
There you go.
I love that name for the Atlas 541. But we heard Jim Bridenstine, our NASA administrator, tell us that if we didn't make this launch period, we would be down for roughly 26 months.
It's
right?
tough.
So the period started July 17th and goes to August 15th. Today, July 30th, was one of those launch opportunities that we had. We had a 2-hour window, and within that window, we had several opportunities.
25, actually.
Yeah.
25 opportunities.
And we launched at the beginning of the window on our first opportunity to get Mars 2020 going on its way. And that, that sounds like a lot, and it is. The flight analysis group, both at JPL, LSP, and ULA, did a lot of work to pick out those target sets and figure out where we needed to be. So they've done a great job, and we'll see how this mission continues.
So, Mick, tell us about the 2 burns required here, and we're actually coming up on the end of the first one. Ultimately, a lot of people probably, and myself included at some point, just like, why wouldn't you just keep firing the engines? Just fire all the way through and get to Mars in one shot.
So the first burn gets us into that park orbit we talked about. We've lifted off, we've left Earth, we've got into a park orbit around Earth right now. And while we're in that park orbit, we will perform some maneuvers to kind of roll Mars Perseverance and the Centaur and coast during that time, basically setting itself up looking at the sun and away from the sun to control the thermal environments that are on Mars 2020 during this coast period. That coast period will allow us to coast around into the position that we need so that we can have that second firing to get the velocity needed to head off into Mars.
Yes, and we will be back for that second burn in just under 30 minutes now. But for now, there's more to learn about this mission and all the amazing science that's involved. Daryl, back to you.
All right. Thank you very much. Great launch and great job, guys. Back outside now to recap. An Atlas V rocket carrying Mars Perseverance rover launched on time from the Cape Canaveral Air Force Station at 7:50 a.m. Eastern Daylight Time.
Incredible. After the rocket took flight, it separated from the first stage and was then boosted into orbit by the Centaur's second stage. Perseverance is now preparing for a second burn that will put it on a trajectory toward Mars. That's just incredible to say. It gives me goosebumps.
It really is, and we're so excited about that as well. And while we wait for that second burn, hang in there with us because we got a lot of exciting coverage to go. We're going to welcome in one of our launch guests, Dr. Derek Muller. He is the creator and host of the popular science education channel on YouTube called Veritasium. He also holds a doctorate in physics education, so he's really smart. And that's why you saw us kind of having some fun, because Derek was here on set and we're just having a good time talking about this launch, which I got to start off with that. Derek, your first time seeing a launch in person, what'd you think?
I mean, what can you say? I have nothing to compare it to, but it was awesome, something I will never forget, and I definitely want to be invited back. So if you guys could make that happen, I mean, just so amazing.
You do a great job explaining physics. What did it feel like? Kind of walk me through as you were watching and experiencing it.
Well, it's like all the physics goes out the window a little bit. It's a very visceral moment between you and this very powerful craft. I think it's just amazing all the, the engineering that goes into making something that's that powerful and yet that controlled,
Yeah.
and to witness that is phenomenal. And then to feel the rumble of all that sound as it hits you, I found it an incredibly emotional experience. It's almost unbelievable to, see it taking off. It's very surreal, that's for sure.
Nice.
Fantastic.
What excites you the most about the Perseverance rover?
Well, the Perseverance rover is going to do a lot of great science. So I'm excited, for example, that it's going to cache samples that we're going to bring back. Super excited that we're actually going to have samples from Mars in our hands. And I think that may clinch whether we can see that life is actually there. But I'm also super excited about Ingenuity, about the helicopter, which I got to visit out at JPL before it was strapped to the underbelly of the rover. And to think about flying a rotorcraft in, another world, essentially, in a place that only has 1/100th the Earth's atmosphere. It seems audacious, and I am impressed and amazed, and I can't wait to see if it works. I'm cautiously optimistic. I think the team is phenomenal.
And you did, in fact, a YouTube story on it, a piece on your channel, and did a fantastic job going to JPL.
I did, yeah, and I was just so lucky that it was like there, a meter or two away from me on the other side of a door in a clean room, and that was, one of the great moments of my life. Yeah,
that thing's going to Mars.
Exactly. Yeah, and it weighs like about as much as my laptop.
Yeah.
And you think about, it's substantial in its size, and it's going to go there and take off and fly all by itself, because of course we can't control it, given the time delay and everything. That is, I just think, one of the pinnacles of human engineering.
Yes, absolutely. Now, this is going to do some big science as well. What are your thoughts on the search for ancient microbial life on another planet, Mars?
Well, I think chances are good that Mars once harbored life. It was so similar to Earth in the past. One can only expect, life probably sprung up there as well. But I'm really excited for us to get that confirmation, because I think it really transforms our ideas about life and how frequent it is. Right now, all we have is this sample size of one Earth with life. If we find another one, that's 100% more information and data, and I think it's likely that life will not be exactly like ours. And I think it'll be fascinating, everything we can learn about other potential forms of life just by finding life on another planet.
You seem to suggest that you think there is life.
I do. I mean, you have liquid water for, I don't know how many, half a billion or a billion years. On Earth, that was enough to create life. So, the guess is that's not a unique thing, right? I mean, the scientific hypothesis is you run that enough times, it's bound to lead to life again in other circumstances.
Dr. Derek Muller, we really appreciate you being here, YouTube creator with the channel Veritasium. We know you have a 2.5-week-old child that your wife is holding down.
There are very few things that I could leave for, but this launch, that is one of them.
Thank you so much for doing so. Get a selfie with our full-size rover back here. You see
Yes,
that?
please.
I definitely will.
Very good. Thank you so much.
There has been a lot of anticipation by NASA teams leading up to this launch, but some won't be able to fully celebrate until the rover has safely landed on Mars 7 months from now. Raquel, you're there with the Mars mission team at JPL in California. How are they reacting to seeing Mars 2020 take flight?
Well, Moo, it's been quite an eventful morning with the earthquake, but you could feel the energy building in the room in the run-up to launch. And now I'm with Bobby Braun, the Director for Planetary Science at JPL. Bobby, now that we've started our journey to Mars, can you tell me how you are feeling?
Wow, it's a great day. We're all so excited, and to get started in this way and to be on our way after all this work that the team has gone through. It's really just fantastic.
That's great. Now that Perseverance is off the launch pad, what are its next steps?
Yeah, well, we're almost on the path to Mars, if you will. The launch vehicle has done great so far. Our partners at ULA are just fantastic, and we're very happy to be working with them and for them to give us this boost so far. But we still have to have another burn of our upper stage. We have to pass through the night side, or the shadow of the Earth, come out on the other side and find the sun and power up, and then establish contact with the spacecraft. And once we do, we'll truly be on our way to Mars. We'll have a spacecraft that's power safe, that we can communicate with, and our journey will really begin.
We look forward to that. Thanks, Bobby. Now, Daryl, As Bobby mentioned, there's an excitement here in the room as the team looks ahead to the second Centaur burn. But before we get to that, let's learn more about the science on board this rover.
All right, thanks, Raquel. And as you mentioned, there are numerous scientific studies and technology demonstrations on Perseverance. Some of these are directly preparing us to one day send humans to Mars. One in particular is called MOXIE. Jeff Sheehy from the Science and Technology Mission Directorate is joining us now to explain, and he is here with us. Sometimes here at the...
A little difficulty with this technology
that's all right.
here, Daryl.
Well, that's all right. It's a Britney Spears style mic, So
like this.
I don't know if you're... That'll work fine. We can hear you. Yeah. Thanks for making the adjustment there. So, Jeff, this is an incredible piece of technology here, this MOXIE, right? So tell us, what is it and why is it important?
Well, MOXIE stands for Mars Oxygen In Situ Resource Utilization Experiment. That's kind of a mouthful, so we grab a few letters out of there and just call it MOXIE. And I think the name MOXIE has a certain kind of attitude that's appropriate for this ambitious mission to Mars. But what in situ resource utilization is utilizing the resources that we find at a destination to produce useful commodities. And so what MOXIE is going to do is suck in the Mars atmosphere, which is mostly carbon dioxide, and produce pure oxygen. Oxygen is a commodity that we can use in our exploration endeavors, and so MOXIE is the first in situ resource utilization experiment on another planet.
How about that?
So that's why it's so important. If we can produce things we need at the destination, we don't have to load them in a launch vehicle, launch them from the surface to Earth, push them all the way to the destination, and land them on Mars or the moon.
Saving incredible weight, fuel, resources to use them, the ones that are there and in place.
That's right. It took a lot of MOXIE. What were some of the biggest challenges in developing this technology, designing it, developing, building it?
Well, the team that produced the hardware that we just saw being launched on its way to Mars, they certainly had MOXIE because they had to overcome a lot of challenges along the way. When you start to develop new technologies, you're working in a laboratory and you've got all the room you need usually. You can build it big and heavy because you're not trying to make it look pretty, you're just trying to make it work, and you've got all the power you need, and you can control the thermal environment, and you can have teams of people come in and tinker with it and fix it when it breaks and all of that. So, but and you can probably see where I'm going with this, when you get to the point where it's time to fly that hardware to prove it out in the space environment or on the planetary surface, then the rubber really hits the road in terms of the engineering, and that's where the teams of engineers come into play, and they develop clever solutions to implement the process that's been developed in the lab and package it for space flight. So MOXIE faced a lot of challenges. You know what? Once you have to put it on the rover, the size becomes important. It has to fit in a certain volume on the rover. The amount of weight or the mass becomes really important. Every ounce you launch into space takes propellant to move it. So we want to make MOXIE as light as possible. Had to fit within a certain mass budget, or they would have kicked it off the rover.
And we're glad you made it on the rover. And just real quick, and without getting too deep into the technical details, how does it convert carbon dioxide to oxygen?
So MOXIE uses a thermal and electrochemical process. There's a compressor that was built by a company called Air Squared. Some of that was funded under the NASA Small Business Innovative Research Program, actually. And they built the compressor. What it does is acquire the carbon dioxide from the Mars atmosphere and push it into the electrolysis system. A company called Ceramatech, a team led by a guy named Joe Hartvigsen. They're now called Oxyon Energy, I think. But they built the guts of MOXIE, which is the solid oxide electrolysis system that takes the carbon dioxide, CO2, actually pulls an atom of oxygen off the CO2, leaving CO.
Oh, wow.
And then those atoms migrate through the electrolysis system, and those oxygen ions are neutralized, and then they recombine. An O and an O becomes O2. And so we get pure oxygen out of the system.
That's fantastic. And so in order for you to get MOXIE on board the rover, actually you had to kind of clear through the very smart lady to my left. She's with Planetary Protection. So she actually had to clean off part of it right?
Yeah.
You had to heat it and then clean the
That's
O2
right.
sensor.
Yeah, the SOx part was actually self-sterilizing. It was hot enough so it cleaned itself. But there's a part, the O2 sensors, that needed vapor hydrogen peroxide sterilization. So it's the first time we used hydrogen peroxide on flight hardware.
Oh, that's awesome.
Yeah.
Yeah. So you can say thank you.
Thank you.
Thank you. No, thank you.
Appreciate it very
Thanks for
much.
letting us do that.
Well, you know, in speaking about the rover, Moo, what is it? You know, Curiosity told us that we have, or had at one time on Mars, moving water.
That's
so,
right.
so what is Perseverance going to do in terms of confirming whether life could have been there?
Yeah, exactly. So the past missions set up the stage as far as understanding what could sustain life, and now we're actually looking for signatures of that life.
And so some of the answers that you're looking for, which one are you personally looking most forward to?
Yeah, I'm personally looking forward to seeing signs of life where no one will argue that it has a biotic source. It's very easy to say, oh, this chemistry could have happened from natural reasons, but I want to see a smoking gun. It would be awesome to see that.
Now, that's not exactly easy, right?
No, not at all.
And so explain that to us.
Yeah, so in order to get that definitive signal, one of the main things you have to do is make sure you have a clean instrument that you're sampling with. And so that's why we spent a lot of time cleaning, baking out hardware to such a high degree, 150 degrees Celsius for some of these parts, to make sure it was clean enough.
And so those parts have to be specially made to be able to handle that heat.
That's right, yeah.
In order to get it past you.
Yeah, all of the material selection, everything was done specifically for that purpose.
Where else in the universe, Moo, do you think we should explore for life?
Yeah, I'm really excited about Europa. Europa has an ocean underneath a thick layer of ice. It has vents underneath that have a heat source, so there's a source of energy for possible life.
Europa, a moon.
Yes, the moon. Yeah, icy moons. That's the next place to go.
It's interesting that you picked that. I mean, it's a very, very cold, cold place.
Yeah.
You've got a rover in front of you that is miniaturized.
do.
We have one that is behind us.
Yeah.
Right? And as part of this, you also had to make sure that that nuclear battery was installed.
Exactly.
Yeah, there it is.
Yeah, this bit back here.
Tell me about how that worked, when you did it, and how that process was.
Yeah, it was only a few days before this launch day. I mean, we just finished counting our samples just a couple of days ago.
How about that?
Yeah, so we had to actually alter the way we sample. We take wipes and swabs of every surface of the rover. But for this, we had to make sure our head was far back and we had as minimal radiation impact as possible. But we got it. It was super clean. INL did a great job. Everyone has done a fantastic job making sure this was as clean as possible.
It's ready to go. What do you think about that full-size rover behind us?
It's incredible. It's like,
Yeah.
hey, you should be up there.
And apparently it is right to scale as you take a shot
Yes.
of it there. That's a beautiful rover. Well,
it is.
thanks for describing all that to us,
Yeah.
Moo. We really appreciate the time
My pleasure.
for you describing that. All right, back into the show now we go. Moving forward, of course, this is the countdown as we go up. You can see the Centaur there in the graphics as we are tracking and continuing to track Mars 2020 on its way. And when searching for the possibility of life on Mars, it's all about location, location, location. And Perseverance's destination is a place called Jezero Crater. Let's go back out to JPL now. And Raquel, you've got a scientist there that believes Jezero Crater gives them the best chance of finding any evidence of past microscopic life.
That's right, Daryl. Knowing where to look for signs of ancient life on Mars can be a daunting task. It took 5 years to select a perfect landing site, and with us now is Katie Stack-Morgan, one of the project scientists who helped pick that location. Katie, can you tell us why we're heading to Jezero Crater?
Thanks, Raquel. There are many reasons why scientists are so excited to send Perseverance to Jezero Crater, and why we think that Jezero Crater is an ideal place to begin a Mars sample return campaign. At Jezero, we think that Perseverance can assemble a diverse set of samples that will help us resolve some of the most important questions about life beyond Earth and the evolution of planets over time. At Jezero, we know without a doubt that there was an ancient lake and river delta. And at Jezero, we have river valleys that flow into and out of the crater, and we know that that lake filled up with water and then overflowed. Life as we know it requires water to survive and thrive, and we think that Jezero has all the building blocks to support past life. At Jezero, we also have one of the best preserved deltas on the surface of Mars, and deltas in lake settings are ideal for supporting life. And the rocks that Perseverance will explore can tell us more about the possibility for past life on Mars. The rocks at Jezero Crater are also some of the oldest on Mars, between 3.5 and 4 billion years old. And that's the same interval of time when life was developing here on Earth. So by exploring the rocks in Jezero with Perseverance, we have the opportunity to explore more about the development of life in the solar system and can answer some of the major questions we have about that fundamental question. Back to you, Raquel.
Great. Thank you so much, Katie. And with that, let's head back to Kennedy Space Center. Daryl?
Much, Raquel. We are back here at the Kennedy Space Center with our most special guest, Moo, and the Perseverance rover. Here it is, a full-scale mock-up of the actual rover itself. Well, Moo, here it is.
Yes.
And so we've learned a lot about this rover so far. So tell me, kind of describe from top to bottom what we're working here. At the top, you've got the mass cam, which is pretty tall, right?
It is very
it's
tall.
towering over your head. It is on a stage, but what does it do?
Yeah, so it has a lot of fun components. Some of them are the Mastcam Z. Z stands for zoom, so you see those two stereo cameras. And there's also that eyeball, what looks like an eye, is actually a laser. It shoots at the rocks.
A laser!
A laser, lasers! And then depending on the signature that comes back, the spectrometer reads it and tells you what the geology is.
And that's fantastic.
Yeah.
Some of the real exciting science, though, is happening right here on this part. This is the articulating arm that comes out, right, and then goes down onto the planet and starts drilling.
Exactly.
What all is here that's going to help us understand more about the geology of Mars, the climate, and whether or not there was life?
Yeah, there's of course Pixel and Sherlock, the really amazing instruments that are going to tell us about the biosignatures. But in the middle, there is the coring drill. The real drill will have a drill bit, a coring bit, which is hollow in the middle. And there's going to be a tube inside. This is just a 3D printed version. And as it's collecting samples, it's going to have samples that go directly into the tube.
Oh, you've got a tube there. Yeah, so
here's
show
a
that on the camera
3D
there.
printed tube here. Yeah. And it's going to go down the middle of the tube as it's acquiring the sample. Once it's done, it's going to dock with the bit carousel here. It's going to ingest the entire bit with the tube inside and the sample. It's going to rotate down to the belly, and there's going to be a little arm on the inside called the SHA, the sample handling arm, to manipulate it, take pictures, assess the volume, and then seal it.
That's fantastic. And so there's quite a bit of robotics happening between this part, the bit carousel, and getting it underneath. As we know, it's now underneath. But here's a special guest, and we're going to duck down. This is the Mars helicopter.
Yes, Ingenuity.
Moo, this thing is going to be actually tucked up underneath the rover. It was a late addition to this project, but it's probably one of the neatest things on it.
It is pretty amazing. 2,400 RPM that these blades are going to spin in counter directions.
Yeah.
It's a little bit under 4 pounds. It's super light. And yeah, it's going to be the first rotorcraft flight on the surface of Mars. It's spectacular.
And you know what's amazing? It will be taking pictures as well, right?
That's
Look
right.
At the blades.
Wow.
These blades turn, right? And they turn in opposite directions.
They do. They do.
It will have a camera on it. It will shoot live or shoot video. That we will then get back. It'll shoot video of the rover as it's doing its work, right?
Yeah, it's spectacular. And look at the clearance. I mean, this rover needs to clear this helicopter after it's deployed.
All right. Well, thank you so much for giving us the tour of the mock-up. It's just like the real one, except for it's not going to Mars. Well, thank you so much. And so by now you may have heard that this Perseverance rover was named by a 7th grader. And it was given that name, which is very special to us. And so we asked Hidden Figures actress Octavia Spencer to tell you why the Perseverance name is more than just a name to us here at NASA.
We are a species of explorers, believers.
We choose to go to the moon in this decade and do the other thing, not because they are easy, but because they are hard.
We are willing to do the hard things, to overcome the many challenges. This is what brings out the best in us.
We are go for a mission to the moon.
Our path has led to success and to bitter losses.
We come together today to mourn the loss of 7 brave Americans.
Yet, even when faced with tragedy and setbacks, we persevere. We keep striving. We keep believing. From space, we see our planet as a whole. We see the challenges facing it, and we face those challenges together. We will not give up. We challenge convention. We refuse to accept the status quo. The time at hand is hard, but we will persevere. We can still draw hope from the moon and the stars, from space, from exploration. There is a new day beyond the challenges we face now.
Curiosity, insight, spirit, opportunity. If you think about it, all of these names of past Mars rovers are qualities we possess as humans.
10, 9, we have ignition sequence start.
But if rovers are to be the qualities of us as a race, we missed the most important thing.
3, 2,
perseverance.
launch commence. Liftoff. We have liftoff.
We are a species of explorers. We will meet many obstacles on our way to Mars. But as humans, will not give up. We will always persevere.
Our collective perseverance is what has gotten us to this day, and now Mars 2020 is on its 7-month journey to Mars with an anticipated landing date of Perseverance on February 18th, 2021. Now we are joined by Dr. Thomas Zurbuchen, Associate Administrator for Science at NASA. Dr. Z, thank you so much for coming over here.
God, I'm so glad I'm here, and I'm so relieved. You know, we have a space mission, and we're in touch with the spacecraft, you know, and everything is nominal. We're waiting, of course, for the second burn, but not quite there, but we're really close.
Yes. So can you tell us what makes going to Mars incredibly hard?
So there's really two pieces that make it hard. The first one is what we're doing today, which is you really need to head in the right direction.
Yeah.
So take it off the Earth and have a lot of energy and head exactly in the right direction, because what you want to make sure is in February, when Mars comes, you want to be right there so you can get captured. The second one, which is the one that's going to make us nervous in February, is to entry, descend, and land. You know, so the Mars atmosphere is almost the worst of all worlds. If it was really thick, you could do what we're doing on Earth, which is go in and with parachutes.
Yeah.
If there was none of them there, you could do, you know, what we do at the moon. When in Mars, you have to do both on top of each other, which makes it 10 times harder than any of the other two, and so that's what makes it so hard.
Wow.
You've devoted much of your life to science, and I know you were asked the other day during a news conference, you know, why another rover, and you gave a pretty impassioned response. Why is this rover important in your mind to the work that so many people are doing in science?
So it's really kind of a key of a whole bunch of new research that we're doing that is focused on a question that for thousands of years philosophers have asked, scientists have asked, and we're ready to answer with the tools of science, which is the way to get reliable answers. And that is there life out there? We have, for 20 years, we've learned about the environment at Mars, and we're ready to ask that now. And the way we're doing it is with this rover. So it's really, for the first time in decades, the first astrobiology mission. We're ready for it. Where it's the next step, and of course there's others coming. You know, Dragonfly. We're already thinking about, and you know, other missions. We want to, of course, go to Enceladus in Europa, you know, and really learn about life there also. So it's an amazing first in that respect.
And whether there's life there or not, that's going to be the answer that we're looking for in these places.
So yeah, exactly.
Yeah, and so we want to do a social media question real quick, if that's all right with you.
Oh, absolutely.
All right.
We have a question from Twitter. What is the key difference between previous NASA missions, rover missions, to Mars, like Spirit, Opportunity, Curiosity, and Perseverance rover? In what way is Perseverance unique from the previous ones?
So there's a fundamental difference in the approach. And the fundamental difference is that we decided to put the instruments on Perseverance, the best geology instruments on this, so we can find the right samples. And we decided not to put a chemistry lab on it. Guess why? We don't know which one yet. And so what we're doing is we're actually collecting the samples that we're going to bring to the best labs that are available to humanity, which are the labs all over the world. And that's the choice here. And that's, of course, to do that, we need to do another first, which is humanity's first round trip to another planet. And that's what makes it different.
We've got more with the launch operation to go, but real quick, how'd you feel about that launch?
Oh, I loved it. It's like punching a hole in the sky, right? It's really getting off the cosmic shore, our Earth, into wading out there into the cosmic ocean. I just love it every time it gets me.
All right, very good. Dr. Thomas Zurbuchen, thank you for joining us. We appreciate you being here to explain all the science and the excitement that's coming up.
Thank you so much.
Appreciate it. Now we've talked to scientists and engineers, and we have shared highlights of the mission and tech demonstrations that are central to the Perseverance rover. And folks, we have a lot more to share.
Mars Perseverance has been flying in space for more than a half hour now. Let's check back in with Joshua and Mick to recap the flight so far and tell us what's coming up next.
Hey, thanks, Moo. Yeah, as you're seeing on screen there, that is, again, the animation of the Centaur in motion around Earth, in orbit around Earth. And you can see there, like I mentioned, the animation being driven by real telemetry data. Mick, how is the report coming back from the first burn and then currently our coast phase?
So we're hearing from Jesse Gonzalez and the engineering team is that everything so far has been nominal. Centaur's been performing well. All the settling firings have been going great, which is keeping the fuel that's still in the tank where it needs to be as we get ready to come up on main engine start 2 for that second burn, which is very important to get us our velocity and into that transfer orbit to Mars.
Yeah, so that will be up in just a few minutes, but I think we're going to actually send you back out to our main desk to hear. Oh, so sorry, I'm being held. We're going to hang out here. So coming up, so talk about C3, Mick. This is something that we talked about having to do with the energy to leave Earth and go somewhere else. We're talking about having to get to speeds over 25,000 miles per hour. That's Earth's escape velocity.
Yeah, so C3 is basically just the technical term that we use in the aerospace industry to refer to the velocity that we need to get the vehicle where it needs to be. So as you said, we got that little over 2 million pounds of thrust that we left Earth this morning with those mighty 4 solids on the Dominator. I still like that from Tori Bruno. Tori, I'm gonna take that one from Tori. But we got off here and into the park orbit with the proper velocity we needed. And then, of course, this second burn is so important for the velocity we need to get in transfer orbit.
Awesome. So the Dominator punching a hole in the sky, as Dr. Zurbuchen said. So we will send it back out now to the main desk and be back with you in just a minute to catch that second burn. Daryl?
All right. Thank you very much.
Thanks so much, Joshua. Joining us now to talk about how special these missions are is Dr. Michael Watkins. He's the director of the Jet Propulsion Laboratory in California, which planned Perseverance's mission to Mars. That is my home center. Thank you for joining us, Dr. Watkins. So we have so many great questions for you. Why are missions to Mars unique?
Well, I think they're unique for 2 ways. And one is just Mars. It's been in our imagination for centuries. It's a place that looks like the Earth. It looks like it could be home to us. It looked like it was once home to to what could have been life. And the fact that we can get there, and we can get there every couple of years, and we can send missions, and we can build on those missions, and you can learn from your mistakes. You can learn from your successes. One of the things I like to joke about is, we say Perseverance looks like Curiosity, but the people who built them are the same. They look even more like each other. And so they, so a lot of our folks worked on Mars Pathfinder, they worked on Spirit, Opportunity, they worked on Curiosity, and now Perseverance. And that, that history, that group of folks, they're just world leaders, and it's why we're successful.
So you oversee the Jet Propulsion Laboratory in California and doing incredibly complex work. Why are these robotic missions so hard?
They're hard because you can't really see what's going on. You can't use your human responses, right? You're used to driving your car and you see what's happening, and you turn the wheel. In this case, we've got to tell the rover, we've got to prepare the rover to do a lot of that stuff on its own, right? And so we've got to understand Mars, we've got to understand how the rover works, and we've got to put all that together into a machine that can function more or less without us. Mm-hmm. So we talk to it once a day, and we say, how are you doing, and go over there and do these experiments, and then it's got to do that. So, you know, we kind of give it its intention, but then it's got to do all those activities by itself, and that's a challenge. And the further away from the Earth you get, the harder it is. So you get out to Saturn, you get to Europa, you get beyond, and it becomes harder and harder.
Yeah. Real quick, one question to wrap up. You've been in touch with the folks out at JPL. On air, there was an earthquake that played out. It was a 3.9 magnitude. How is everybody doing? How's your team?
They're doing great. You know, our view is just Pasadena. It's just the Earth being excited about going to Mars. So it was a very minor earthquake. We have them a lot in California.
Okay.
You know, maybe it's like hurricanes here or something, but it's tropical storms here. But it was a very minor event, and everything's fine. And we are on our way to Mars.
Okay, so a little rumble here in Florida, some rumble in California. It works out great. Mike Watkins, thank you so much. We appreciate you joining us on the broadcast.
My pleasure. Thank you.
All right.
Awesome. We will have that conversation, a conversation with Zena Cardman coming up, which I'm super excited about.
That's right.
Yeah. On the other side of the Centaur burn and spacecraft separation. We'll also highlight 6 major technologies that NASA's focusing on over the next decade, including the critical energy needs for such missions. But with that, let's turn our attention to the next operational steps. Joshua, are you there?
Yeah, Moo, we're here and we're excited. We have a fuel pre-start call just coming in. We are getting ready to hear the call for this second burn of that Centaur RL-10 engine. Again, Mick, explain what this second burn is for.
So as we talked earlier, the second burn is really to get us that velocity as we head into that transfer orbit, right? Centaur and Mars 2020 will head into that solar orbit on its way with the proper velocity. We will then get ready to separate Mars 2020 on its way. And I'm hearing that settling is done, and we have main engine start.
There we go. Awesome. And again, that animation there being driven by actual telemetry data coming from that rocket. So that's a phenomenal sign. And again, I think that it's tough with these images. Perspective and scale are so important. This vehicle is in Earth orbit. It's not near anything, so you can't see the acceleration of what's happening right now. But for 8 minutes, it's going to be picking up speed.
Yeah, this is the burn that gets us really moving in the direction we need to go, that fast velocity that we need to get out of our park orbit and head on our way to Mars. Of course, Centaur and Mars 2020 are still together, and as we're hearing, everything is looking nominal on this fire so far. Main engine start was good, and the firing is going well, nominal, as we see in the animation there.
Fantastic. So this is rocket science, and it's not easy. We actually want to bring in now, we have a special guest. This is Dr. Denton Gibson, excuse me. Yes. He is a rocket scientist. His official title is Senior Vehicle Systems Engineer. Denton, how are you doing?
I'm doing well. Thanks for having me.
Yeah, did you enjoy that? Obviously, you got to kind of spectate. A lot of days, you guys sitting on console, you have to kind of focus on your computer, but you got to see this one today.
Oh, yes, and it was a beautiful launch today.
Yeah, nice sunrise. Hey, tell us about your role with LSP. I was not making up things when I said you're a rocket scientist, but what exactly do you do?
So as our role in LSP, as a vehicle system engineer, we are the engineering team lead for a lot of the rockets that we launch our science missions on. And we are responsible for the oversight and insight into these launch vehicles for the NASA.
That's awesome. And I know in the past you've supported a variety of vehicles. Tell us a little bit about the vehicles that you have supported and the ones you're focused on today.
Yeah, so some of the vehicles I supported in the past is the Delta II, which was a long-time workhorse for our science missions, as well as the Pegasus and Taurus/Minotaur C. And right now I've been focused mainly on the Falcon 9 and Falcon Heavy.
Yeah, awesome. So obviously not focused on the Atlas V, but a lot of that experience and the process is the same. I want to take a moment to pause and say Denton's there at Hangar AE. That's the NASA Launch Services Program's hangar. They're very proud of that. We call it the telemetry center of the universe. That's where the data for today is flowing. But I wanted to also ask you, is the process the same for all these vehicles? When we talk about the telemetry and these sort of processes of getting from Earth to Mars, does Falcon 9 experience translate to Atlas, or are they completely separate?
So the overall process for many of these launch vehicles are the same, whereas you ship stages to the launch site and assemble the launch vehicles by stages. So in that sense, they're the same, but there's a lot of differences between the launch vehicles that may change that process a little bit. But in general, the processes are the same.
Yeah, and Joshua, I was going to say, Denton, I worked with Denton quite a bit over the years, and he talks about the different vehicles he's worked on. But Denton is one of my senior vehicle engineers in LSP. And so although he's not totally supporting Atlas V today, he does have experience with Atlas V. And as he said, things are very similar. So using his experience, we're able to train and bring on new generation of engineers, and Denton's been a huge part of that to allow us to grow our bench, if you will, to start working commercial partners.
Yeah, awesome. So Denton, tell us a little bit about kind of what's involved, what goes in behind the scenes, what's the rocket science of going from Earth to Mars, this maneuver to go into solar orbit?
Yeah, so a lot of the things that happen behind the scenes it's a lot of analysis work done by our analysis teams. I mean, it's months and months of analyses that are performed based on the orbit insertion, the performance of the launch vehicle. A lot of modeling and simulations is done to be able to get to this point to where we can transfer from Earth orbit into solar orbit.
Awesome. And obviously you're a rocket scientist. That's for a lot of people, that's like the pinnacle. That's like, hey, I want to be a rocket scientist. So where do you go from here in your career? Because obviously, like, I'm sure there's lots of things that you'd like to go and accomplish.
So, you know, going from here, I mean, one of the coolest things about this job of working in the launch services program is working the launch, right? I mean, who doesn't love a launch, and who doesn't love working launches?
Yeah, we love them. We love them. Excitement this morning, right, Denton? We got to see that's what it's all about.
Of course. So, you know, one of the ideal jobs would be a launch director, because you get to work all the launches. I mean,
Very
how cool
good.
is that?
No, yeah, that's true. And I guess you get to, is it right to say you call the shots, or is it that the buck stops with you, or how would you say that?
I'd say the buck stops with the launch manager. As today we talked, right? Omar Baez is our launch manager for Mars 2020, and he had to poll the team and make sure everything's ready to go. So the buck does stop with him right there on today's launch. And as Denton says, I think there's a lot of people that would love that job, and Denton's definitely looking at that next step. So I guess we need to give Omar and his assistant launch manager, Tim Dunn, a heads up.
Yeah, there you go. Dr. Gibson.
Dr. Gibson is
Up
on
and
the
coming.
way. Yeah.
Awesome. Well, Dr. Gibson, before we let you go, give us a real quick snapshot. I know you have a mission coming up later this year. What are you working on?
So, so we're supporting the Crew 1 launch coming up. So we're helping commercial crew out with that one, as well as Sentinel-6 as far as the LSP missions. That's coming up later on this year. And so we're excited about that one.
Yeah, a ton going on. Dr. Gibson, appreciate you. Thanks. And I want to take a special moment on the commercial crew note to comment. We've got a big day coming up.
Yes.
Pending weather. There's a tropical system that might kind of get in the mix here, but we have a tropical system that could create some problems. Otherwise, we've got Bob and Doug from Demo 2. They're coming home on August 2nd.
Yes, I was going to say, Joshua, that's important for us also in LSP. Denton was my lead VSE, along with a few others that are in the group that worked that mission with the commercial crew program. And so it's really important for us to be able to support other programs within the agency to make these things happen. As we launch Mars 2020 today, which is another step for us getting humans to Mars, right, is getting humans launched off of Earth soil was a huge step for off of American soil.
Yes,
was a huge step for us.
Yeah, and so talk about that really briefly with LSP. Obviously, Denton there, appreciate him and his contribution, and you working towards commercial crew, but also supporting Artemis, which is also part of that path of getting humans to Mars someday. Artemis is about learning to live on the moon to sustain a presence there with the eyes on Mars. So how is LSP supporting even Artemis?
Yeah, one of the things there is the Gateway program, right? Deep Space Logistics that is working a lot of that. And so LSP is in the works of supporting Gateway and helping them work with the commercial partners that are providing the rockets for those kind of missions that are out there and future things. One of the cool things about working with the Launch Services Program is that we work with all of our commercial partners, SpaceX, United Launch Alliance, Northrop Grumman Space Systems, and of course some up-and-comings. You may have heard some, right?
It is
like
a growing
Blue Origin.
field. Yeah.
It's definitely a growing field in the aerospace industry, and LSP takes pride in working with those commercial partners to figure out what we can do for NASA and the country.
Awesome. Yeah, it is an exciting time for spaceflight. The commercial spaceflight industry is booming. There's always new things happening. If you keep an eye on the news, you will see new things. We're getting word now that the engine cutoff here should be happening momentarily. Once we see that happen, we'll have roughly, I believe it's 5 minutes until we actually see the spacecraft separation occur. So we're going to stay with you through that, but want to kind of just preview that for you, that hopefully on screen here you should be seeing that engine cutoff, and that's completely expected. That's a nominal operation, as you say, Nick.
We'll hear from Jesse Gonzalez, who's looking at the launch vehicle telemetry and watching the animation there. So let's listen in for Jesse here.
And there's the call, and there's the animation, again, modified based on
The
data.
RL10 shutdown parameters
let's talk about communication for a minute, Nick, because it is not an automatic thing to just shoot information at Earth and have that be usable. So how do we go about communicating not only through launch, but on the way to Mars, and then once we're at Mars?
Yeah, so the important thing this morning is when we lifted off from Complex 41 here at Cape Canaveral Air Force Station, we had ground stations that were looking at the launch vehicle and tracked it all the way to provide data. Once we got onto orbit after stage separation, you heard a call out for TDRS, the telemetry network that NASA owns, which, by the way, is also used for the ISS and will be used hopefully for the landing with Doug and them.
Yes.
So getting off the ground today was great because we could deconflict some of that TDRS usage, right? But TDRS is very important for us to be able to get the telemetry from the launch vehicle back down to Earth here. And then, of course, when Mars 2020 separates and it gets on its way to Mars, then the JPL team will take advantage of NASA's Deep Space Network, which has been around for a long time, to be able to transmit commands and data back and forth to the Mars 2020. So it takes a lot of folks to work those, and the TDRS and Deep Space Network are very important to not only the science missions, but human space flight also.
Yeah, and I think the coordination of that is something that people don't get a chance to understand much, because as you said, we're using TDRS for crew return, we use TDRS for space station, and TDRS is not an unlimited resource. We have a good number of TDRS satellites in orbit that help us do these things, but it is a coordinated effort across the globe, because we even have ground stations in Australia, I think. Yeah. Where are all of our ground stations even?
We have ground stations everywhere, not only here in America on the West Coast and East Coast, but then you get into South Africa area, Australia, you said. We have several ground stations that catch up different things for missions, but of course in orbit, TDRS and the Deep Space Network are very important. And as you said, there's not an unlimited amount of resources there in the TDRS network. So we have to coordinate those things within the NASA agency and with our commercial partners when they're used for our launches. And again, that's another part of what NASA does as an agency.
Yeah, so just on that note, kind of thinking about around the world, currently this spacecraft is roughly over the South Indian Ocean. So that's just thinking about how fast we're moving, just the amazing world of spaceflight. It's just hard to put into words sometimes, of like we're literally flying around the Earth and we're already halfway around it. And so I want to talk actually about planetary protection some more. I know we heard about that a little bit from Moo, about how they're working to protect Mars from contamination, so to speak, just putting things there we don't want, and we have to consider that, or ULA has to consider that when they're flying to Mars and delivering the spacecraft.
Yeah, it's a combined team. ULA, JPL, LSP had to look at that for when we get ready for spacecraft separation here in about a minute, right? One of the things we talked earlier is that Centaur and Mars 2020 are on the same path towards Mars right now. So once we separate, Centaur will do a CCAM maneuver, or what we call a contamination and control avoidance maneuver, and then blow down what's left of propellants in its tank. And by doing that, we have now put Centaur on a different track so that it will not intercept Mars or interfere with Mars 2020 at all for approximately the next 50 years.
Yeah,
and that took a lot of work by the JPL team and the launch team to make sure that would happen. So again, another planetary protection maneuver that had to be done.
Yeah, and I understand from the telemetry experts in LSP that this rocket actually, after the second burn, is not actually aimed straight at Mars for that reason. It's actually aimed slightly off of Mars, and so Perseverance, Mars 2020, will redirect itself just slightly. We're not talking about over 7 months. A little bit of difference here makes a lot of difference later.
Absolutely. And Josh, we heard Jesse telling us that Centaur is spinning up. This is the maneuver right prior to spacecraft separation, where we get into a slight roll to give Mars 2020 some
stable Centaur tank pressures,
stability.
Very good performance from the RCS system, and stable indications from the avionics systems as well.
So RCS there, the reaction control system, that's those small, the series of those small engines that you see firing around the spacecraft. Those are used for that in-flight operations that they need. The rolling activities, as Mick's saying, is basically providing stability to the flight of Mars 2020 as we go forward. Tell us about actually...
And we have successful separation of Mars 2020 with the Perseverance rover.
There we go.
Awesome. We got some nice applause there. That is a big moment. We are hoping to get some live video back from that because of the time delays with communicating with things in space. We don't have it at this instant. We're hoping we'll get to see that here in a few minutes, and we'll bring that to you if we do. But tell us about the separation maneuver, because the apparatus, the actual... It's a really simple design.
It's a separation clamp. We'll talk about that in a minute, but as you see on your screen right now, you see the Mission Director Center where Omar Baez and the team are. And Josh, you and I joked about this a little bit earlier, but with the pandemic and everything going on, the teams have done a great job. Normally, spacecraft separation.
2020 with the Perseverance rover, the Centaur will now perform its standard propellant blowdown sequence to inert the vehicle and complete today's flight after completing its CCAM avoidance maneuver. This will conclude today's commentary of the Mars 2020 mission. This is Atlas Flight Commentary signing off.
So that's the end of ULA's job for today.
Jesse Gonzalez did a great job with the ULA commentary this morning. But what I was saying about the Mission Director Center is normally we would see a lot of clapping, a lot of hoop hollering, a lot of handshaking. Yeah. But with the pandemic and everything, people are staying their distance, taking the guidelines seriously, wearing masks with this. So we saw a lot of air fives, right?
Yes,
and stuff.
absolutely.
So that does not take away from what the team is, how excited they are. They have done a lot of work to get to this point, and that seeing spacecraft separation is awesome. So, but
and throw all on top of all that, 2020 was like, here, have an earthquake,
right?
So it's just we did it. Like we're most of the way there, not there yet.
Yeah, as you heard Omar earlier in the broadcast say, a lot of us when we started this, when the pandemic started, we kind of thought Mars 2020 might be Mars 2022.
Yeah.
But Mr. Bridenstine, the NASA agency, decided to move forward. The teams found ways to do this. As we heard, they were disciplined, they were focused, they were courageous. And all that played off today with a successful launch at 750, and now spacecraft separation, Mars 2020, Perseverance and Ingenuity on their way to the red planet.
Hey, we're going to wait for acquisition of signals. Stay with us, but really fast, Mick, tell us very, very quickly about this mechanism, because we teased it.
We teased it, yeah.
How do these things separate?
So the separation system is called a Marmon clamp band, actually designed earlier by Karl Marx, one of the Marx brothers. Very simple design, but it has some spring systems in it that once the signal is sent and the bolts release the clamp band, the springs basically just give just enough force to push the spacecraft off the front of the vehicle.
Awesome. And again, hopefully we'll see that video here momentarily. But for now, we're going to send it back to you and check in for one final time in a little bit with the folks here at ASOC. But Daryl, back to you.
All right, thank you, and great job, both of you, Joshua and Mick. It's always great to see Mick explain that springs are what's getting us to Mars. All right, so we've got our second burn underway. We've been flying for right about an hour, and as you just saw, spacecraft separation went well, and so that's fantastic. We can now say that Perseverance is officially on its way to Mars.
What a beautiful thought that is. And while NASA has been tracking the spacecraft since launch, with its tracking and data relay satellite system, I know the mission control team at JPL is turning their attention to the next milestone, and that is ensuring that the array of communication antennas known as the Deep Space Network, or DSN, begin to receive a signal from the spacecraft flying the Perseverance rover to Mars. We expect to see the teams acquire the signal close to 9:14 Eastern Time. Though, as you saw, the spacecraft separation has occurred in the shadow of the Earth and out of line of sight of the system, so this could take a bit longer than estimated.
All right, and so finding life on Mars won't be as easy as you might think, and we talked a little bit about that. Here to talk about that and more is NASA astronaut Zena Cardman. Zena is here to join us, and we're so glad that you're here. Thanks for taking the time. First of all, your reaction to that launch.
Wow. Every time it takes my breath away. I had actually never seen a launch before until I got this job as an astronaut, and now I'm very lucky to have seen 3. And every single time, it just makes me feel so much emotion.
And kind of talk us through, I mean, it got up quick, right? So as you were watching it, you feel the rumble?
It did, yeah. First you see it go up, and then you feel the rumble as the sound travels to you, and you can really feel it in your chest. It's amazing.
Very good, very good. Talking about astrobiology now, you have an amazing background. You've searched for signs of life in some of the most extreme environments on Earth, the Antarctic, the Arctic. So you're used to looking for these biosignatures. What are your thoughts about this rover searching for signs of life?
Yeah, you know, we have a lot of experience looking for signs of life in unusual environments here on Earth. So if you take a look at Mars today, it's very cold and very dry, and we have some places on Earth that are actually a lot like that. So places like Antarctica or deserts. But if you want to look for signs of ancient life, life that existed billions of years ago perhaps, when Mars looked maybe a lot more like Earth does today, you have to know what those signs of life left behind in the rock record. Because microorganisms are very tiny and very soft, so they don't leave a fossil the same way a dinosaur would leave a bone or a footprint. So instead we use these chemical signatures.
Daryl's dreams is shattered again. We told him there's going to be no dinosaur bones on there. He really wanted them.
Something wiggling around, but no.
So why do we need to go to the moon before we go to Mars?
That's such a good question, because we've been to the moon, right? But we haven't been to the moon to stay. We really don't know how to live off of Earth on another planetary body, and we really need to figure out how to use resources, use tools, especially if we want to do geology on Mars. The tools that we use here on Earth are going to look pretty similar, but they might not work quite the same way. And because the round trip to Mars is so much longer than the round trip to the moon, when we go, we want to do it right.
Very good. And how do you like that rover behind you? Huh?
Oh my gosh, I love it.
Yeah, it's great. Hey, I want to ask you some social questions now. These
Absolutely.
are some from our audience who have been watching.
Oh,
so
great.
We appreciate you doing that. Our first question comes to us through Facebook. Thomas asks, will Perseverance land to investigate the landing site for a future manned mission in the same location?
Yeah, you know, that's a really good question. I think one of the most interesting things about doing a mission to Mars is choosing where you're going to go.
Yeah.
Because, you know, you can imagine planning a mission from Mars to the Earth, and if something landed in Utah versus landed in the ocean, your vision of Earth might be quite different. So one possible approach is taking a human mission and going back to somewhere where these rovers have been already, or maybe we'll decide to explore somewhere new. I have no idea yet, but I can't wait to find out.
Awesome. It looks like we have another social media question from Twitter, from Huda. Do you think that in a few years we'll be able to send astronauts to Mars in a safe way if we are able to send a rover like Perseverance to Mars in a safe and amazingly planned way?
I hope so. We won't go until it's safe for humans for sure, and we're not going until it's a round trip. But actually part of this mission, of course, is a round trip, and so we will eventually learn how to send a rocket to Mars and then have something lift off of Mars and come back.
Well, Zena Cardman, thank you so much for being here. You did a fantastic job. You were a great guest, and glad you enjoyed the launch.
Oh my goodness, it's impossible not to.
No doubt. All right, thank you
both.
Now, as you can imagine, there are a lot of systems to develop and prove out as we prepare for sending humans to Mars, as you just heard. Here now are 6 technology disciplines that are critical to the success of our future explorations. NASA's first Mars rover were powered by solar energy, but dust storms caused issues by blocking much-needed sunlight. So NASA upgraded to nuclear batteries provided by the Department of Energy. And joining us now is the Assistant Secretary for the Office of Nuclear Energy, Dr. Rita Barnwell. Thank you so much for being here.
Great. Thank you for having me.
First
Excited
of
to
all,
be here.
how did you enjoy the launch?
It was amazing. Absolutely amazing. So fortunate to be able to be here and be invited to watch it. I'm just giddy.
Had you ever seen one before?
No, I hadn't. It was my first one.
And what'd you feel as you were?
It was, you could literally feel the launch. So it was very exciting.
Very good.
Yeah.
So it's really interesting. When I saw this segment, I was just fascinated by the whole nuclear part of this. This is right in your wheelhouse. So explain to me, how did the Department of Energy get into the business of making nuclear batteries for space exploration?
So space exploration requires power sources for the long-lived missions that we need for this type of activity, for heat and electricity to be provided to the spacecraft and the scientific instruments. And nuclear energy can certainly provide that power. One source is the radioisotope power system, RPS. Part of that RPS is the radioisotope thermoelectric generator, and RTG. I know that's a lot of acronyms, but you got a decoder ring, so I hope you're good there. A space nuclear power system that converts heat into electricity without any moving parts. RPSs work by converting heat from the natural decay of radioisotope materials into electricity, and that's what we have up on the rover that just got launched this morning. Yeah. It consists of two major elements: a heat source that contains a radioisotope fuel, mostly plutonium-238, and solid-state thermocouples that convert the plutonium's decay heat energy to electricity. DOE developed several generations of nuclear space power systems that can be used to supply electricity and use the excess heat for a variety of other space applications. This one that was launched is called the Multi-Mission RTG, and it was designed with the flexibility to be able to be operated on planetary bodies with atmospheres just like Mars, as well as in the vacuum of space.
It's amazing the longevity of that battery.
Yeah, I heard it could last up to 14 years.
Right.
Will it actually last longer than that duration?
It can, and actually right now it was 17 years, 3 years here, and then 14 years out in the mission itself. So we're very excited about that. That's one of the benefits of powering this mission with nuclear energy. The RPSs that are currently powering Voyager 1 and 2 that are exploring the extremes of our solar system also are being powered by an RPS that has lasted for 43 years. Wow. And that's a long time. That's a great extent of time. Yeah. The MMRTG is essentially, it's a nuclear battery, like you said, and it contains only 10.6 pounds of plutonium dioxide fuel, and it provides 2,000 watts of thermal power. It's similar, the material that's used in this is similar to what was used in the two Viking spacecraft that landed on Mars in 1976. Wow.
So this technology has been around a long time, and it's well proven.
Yes.
Dr. Rita Barnwell, we thank you very much. The Assistant Secretary for the Office of Nuclear Energy. Thanks for coming out. We're so glad you enjoyed the launch, too.
Thank you for having me.
You're welcome. All right, here's a statistic you might not know about. Missions to Mars, roughly half of them actually make it there. Imagine that. But right now, we know the health of the Mars 2020 rocket is good because it's sending back a stream of data to our telemetry nerve center here at the Cape. Let's go back now to Joshua Santora to learn more about that. Joshua?
Yeah, thanks, Daryl. So we talked to Dr. Denton Gibson, who is one of the guys that works behind the scenes, but there is a group of folks that work behind the people behind the scenes, and Jessica Connor is one of those. She's coming to us now from the same Hangar AE location. Jessica, thanks for joining us.
Hey, it's a pleasure to be here. Thanks so much for having me on.
Yeah, so tell us about what you do to help make all of these activities, and as Daryl mentioned, the telemetry happen. What do you do for, what's your role for LSP?
So I work as a mission communications engineer for LSP. That means that I'm getting the video, data, and voice requirements from the spacecraft and then ensuring that they're able to go ahead and perform these operations once they actually get to pad phase.
Joshua, I was just going to say, Jessica's one of our wizards. You said behind the scene within the launch services program as engineers, we depend on our folks at AE to make sure that we get everything we need to do our assessments as engineers. So they make everything possible there.
Yeah, absolutely. So Jessica, tell us a little bit about how you get the data back and then how it's utilized out to the team.
So while it's on the pad, we go ahead and get that data through the umbilical lines, and then that goes ahead and goes back to the engineers, and they're able to provide fleet insight based on the data that they get from the consoles.
And can you tell us about how long you've been working this mission? People probably don't understand how much time goes in ahead of time behind the scenes to make these missions happen.
So I've been working for about 2.5 years on this mission. About 2 years out, we start working with JPL to go ahead and get those requirements, and then we've been working with them since to go ahead and get processing video, and also being able to talk back to JPL, being able to talk to headquarters and stuff like that.
Awesome. And so what's been the biggest challenge for this mission? I know that this mission's presented a lot of unique challenges for all of our teams, but for you, where has that challenge lied?
So we have a ton of experience from different mission comm engineers from the past, and so the most unique thing about this mission has been our treatment of COVID, and it's amazing what we've done to go ahead and keep the control room safe for all of the people on console, and to go ahead and launch this mission on time and successfully.
Hey, listen, and we did it. We have the data coming back,
Yeah.
so that means that I think that means you did your job really well today.
I would say they did their job great, Joshua. They found new ways, as we talked earlier with the launch team, finding new ways to do their stuff. The folks out at Hangar AE also found new ways to make sure that all the engineering team could perform their fleet's insight assessments and support today's launch. So that team out there has done a great job. They actually make us in engineering look good. So we appreciate all the work you guys do, Jessica.
Yeah, awesome. Jessica, congratulations. Job well done. Thank you for joining us for this interview today.
Thanks.
All right, so Mick, things are pretty quiet now, and that's expected because we're just hanging out for the signal acquisition. The time there is the estimate based on the pre-launch data.
Yes.
Right now, we're actually in the shade of the Earth, so we're behind the Earth, and so we'll come out of that at some point shortly, and then hopefully acquire that signal because there's some solar rays that have to play in here. So still kind of some. I don't know if tense is the right word, but we're anxious still.
Yeah, I would say we're anxious. We're focused still. As I like to refer back to what Tori said earlier, right? Focused and disciplined. Even though it's pretty quiet right now, we have had spacecraft separation, which was a huge milestone for the team, an exciting time for us at NASA, ULA, JPL, the DOE, and our United States Space Force family. But the team is still sitting on console. They're still following their procedures. They're still performing everything that needs to be done as we await the acquisition signal. Some of the things that are going on here behind us is ground securing and everything here at the complex to make sure we can safely enter and do the work. So
yeah,
a lot of work still going on.
Yes, and we're going to send you back to Daryl because we need to check in and talk to the folks who are going to be getting that data back. So Daryl will check in for one last thing in just a few minutes.
All right, thank you very much.
And you can imagine driving out into the countryside and you're farthest from the nearest cell phone tower, and you look down at your cell phone and you see one bar, a very faint signal. And as you mentioned, Mars is very far away, so you get a very faint signal, very much less than a 1 bar. And so thankfully, we have on the ground from our Deep Space Network managed out of JPL, very large antenna dishes that can detect that very faint signal. You're talking about a signal that's basically like an incandescent light bulb, and receiving that from millions of miles. We have 70-meter antennas and 34-meter antennas. A 70-meter antenna is about the size, to give some context, about the size of a 20-story building. So very large systems that can detect that very faint signal.
Great. And the Deep Space Network also communicates with all of our other missions beyond the moon. Now, how far have we gone into space?
Well, our Voyager missions are the farthest and fastest human-made objects that exist. Voyager 1 is nearly 14 billion miles away from Earth. It takes almost 20 hours one way to communicate to it. So once again, you can think about that light bulb. Could you imagine turning on a light bulb or a light switch and that light taking 20 hours to get to your eyes? And so basically, to communicate to Voyager, we send a command saying hi. It takes 20 hours to get there, and every 20 hours to receive a response from Voyager. So very far away. Thankfully, Mars is not as far away as you mentioned, several million miles, not billions. So it takes not 20 hours, but it takes about 7 minutes. So it's a little better situation there.
Wow. So what does it take to add the Perseverance mission to the Deep Space Network?
Well, it's a lot of pre-work before the launch. We test with the launch vehicle, we test with the spacecraft, we test with the rover. We test over and over again to ensure that when it launches, when the spacecraft separates, when it lands on Mars, that we can have confidence that it will be able to establish a communication with us back on Earth. That's very important, and we instill that confidence by testing and making sure we have a lot of testing up front. And the payoff comes when we see those great, awe-inspiring images from Mars. And so a lot of testing happens up front, and a great team that works on that.
Great. Now, getting an acquisition of signal is a very significant moment. Can you tell us how it works and what we should expect to see for this mission?
Yes, that's a very important moment. And sometimes you'll see a spectrum graph that's a couple squiggly lines in the bottom, and what you expect to see is a peak in the middle come up, and that's what you call the carrier signal. And the carrier signal is described as a carrier because what it does, it brings in the signal. It carries the signal to us. Therefore, we can see that signal and know that we're receiving data. And basically, we see the carrier signal, but after that, we have to decode what the signal's saying. And hopefully what we're seeing is that the spacecraft is saying, hey, I'm doing okay. I'm on my way to Mars, and I'll see you there in 7 months. And so we expect to see that signal, and then we'll decode it and be able to get the health and safety of the spacecraft. But also what we'll also look out for is how to track it. So once we have the signal, we'll lock onto it. We'll move our very large antenna dishes, and as the Earth spins, we'll track the spacecraft around the globe. This is a global effort. We have our station in Canberra, Australia, and Madrid, Spain, and Goldstone, California, who will all be part of this tracking as the spacecraft goes to Mars. So very exciting time, and we're looking forward to hearing from Perseverance shortly.
Great. Thank you, Philip. Now, we are just a couple minutes away from the first opportunity we will have to see if the Perseverance signal on the Deep Space Network is up on our screens. That moment brings us one step closer to Mars, but we have many other milestones to hit over the next 7 months, and I'm with Perseverance's Chief Engineer, Adam Steltzner, who will tell us what's in store for the rover. Adam, what should we expect to see next?
Well, Raquel, we are... After we acquire signal, we have left the building. We are on our way to Mars. We're no longer in orbit around Earth. What will happen next is we will start our cruise phase. It'll be about 7 months before we make it to the red planet. We have a set of planned trajectory change maneuvers that we do during cruise to adjust our targeting. In fact, we're targeting to miss Mars right now. We're on the way, general direction of Mars. But in order to make our Atlas Centaur, which threw us in the direction of Mars, not run into Mars, we're on a missing trajectory, and we'll do TCM-1, which will target our impact with the Martian surface in a few days. So we start to monitor the spacecraft, make sure it's healthy and happy, and tweak its trajectory to be right on target by the time we make it to Mars.
Great. Thank you so much, Adam. And right now we are just a minute away from the acquisition of signal, so let's pause for a moment and watch our teams at work.
stage flight. We'll be waiting for indication of acquisition of signal.
Ace copies. M20, ma'am, ready signed, report initial acquisition.
That's it. Copy that, radio science.
Flight nav.
Go ahead, Nav.
We're seeing one-way Delta. 346 AOS.
Didn't copy, Nav.
Yes, sir, we see AOS at 131531.
Ace copies, thank you.
Flight telecom, I was about to pull up my contingency.
We now have an acquisition of signals. The rumbles now are of claps and cheers, and it's an amazing